Hello, in this lesson, we are going to dive into our DAC vacuum where you're going to be using red for this. So let's just start. On your project, we have a kind of skeleton project to start with. And from the course 1, we are going to have here the Docker with the red setup for us to start. So we're going to just go to red and the command line. We are going to just run the Docker compose, click red. We're going to start. And then we are going to go straight to the browser. And in this browser, we are going to just start our Reddit client in the browser, where you're going to follow the course, basically some guide to play with Redis and vector search, which is this one here. So you can learn about document, time series, but we are interested only in the vector similarity search, which we're gonna be using in our project. The introduction basically talk a little bit about the Redis search, vector similar search, and here they mention some few most common applications to build on top of the search. Could be visual similarity, so you can basically give it a image and they'll be searching all the image that is similar to that. And you can see here basically some similarity based on recommendation and the chatbot systems where you can find similar question, which it is very similar to what you're going to be doing to our project. Moving on, next step, we're going to be basically creating some flat vector index. You have the two types of index in Redis, this flat vector index, which is used when you want to optimize the occurrence or when you want it to be more generics. So this is, you can use both at the same time, right? So here you can see how to create a index in Redis. So basically give you the name for the index. You can use any name here. Just stick with the word suggestion. So it's an index based on a hash data. So you're gonna see that the data is based on the Redis hash, and then you're gonna index all that data and be able to be just doing some queries. So we're gonna be querying all the data that is prefixed with product. In our hash can have many data, but we're not going to do all them. We're gonna just focus on the product prefixed keys. Then here we're gonna have a name as a text, a price as a numeric, and here it's basically the column that we're gonna have in our index. And here we are gonna use an image vector, which is basically the vector that would be used for search and do the semantic searching thing. In this case, we're going to be using image vector, but in our project, we're going to be using a vector that is any vector. Here, just the parameter that we have. What is important here is dimension. So 512 is the type of dimension that we're going to have in our data. And the other important thing is the cosine algorithm that would be used to calculate the distance between the given data and the data that will be on the database itself. So that is the algorithm that's going to be used, and everything else is just people specific to Redis itself. Let's run it. Let's also create this approximated nearest neighbor that is safe that is best for speed. It's quicker, and let's clear it. Then we're going to go to the next one. And now we're going to visualize, you're going to be adding some data. So we are doing the hash set, that's the Redis command to add the new hash data, right? So here we can see that the key we are using prefixed with product, right? As we specified on our index that will be using this data. And here we are just setting any data that you're going to be adding. And you can see here the image vector, here there is a vector. This was already kind of translated to string. Vector, you're going to see that's a bit different. Vector, it's a matrix. And this, he was basically, they were decoded into a string. But yeah, let's insert this. So basically, we inserted to the hash that Redis data, and we are going to see later that it will be already indexed in our index. right? That is two different things. One is the data itself in a hashtag data, and the other it is the indexed data, which will be basically taking this data from our hash and put in a kind of similar sort of table that we are more familiar with the relational database. Okay, we're gonna add one more product here. We're gonna check our index. Basically, we added some data, as I said, to the hash table, and we're gonna check the index itself. And here our index, you can see, with the name, price, and image vector, and the names of the attributes and the types and the weight here. The same for HNSW, you can see the thing. So you have two different indexes of the same data, basically. One optimized more for occurrence, and the other is more optimized for the speed. Right. Now we're gonna do some queries against the index itself, not on the hash table. This is kind of red specific query that basically gonna be doing everything from this KNN near and canary. It's kind of the algorithm, forgot the name. KNN. Let's say there's two parameters, and here's basically the main column that we'll be using, and we're gonna be comparing against this query vector data that it's passing down here. That you kind of get this query here. I'm gonna give an image, and I wanted to see all the similar image to the given query. Down here you can see that we're gonna be returning three columns. One is the score of our queries for each item, and name and price for a name and price of the product that is similar to the given query, to the given image. We're gonna be sorting by the score, the most similar on the top, and using the dialect tool here, which is very specific to red as well. Let's see. The result of the query that you just run is this one. So a very similar image, it is the mobile phone, and you can see the price down here and all the column that we specified that to be returning. Now we're going to do the same with the second index, basically the same, just change a little bit the parameter, but it's basically the same. While you run, you can see that you get the same response from different indexes for the same data. So that's very important to understand here. The data is separated from the index. So you query against the index and not against the source of the data. We can use different queries as well. For example, here it's the same we did before, but now we are saying that you want price entry 70 or 80. And you're gonna see that before we had two items here, and now it's supposed to return only one that is between the parameter that we passed, which it is between 70 and 80. So 78 should be the response. Yeah, and we got it here. So this is all what actually we need to know for a project, right? This is not, of course, a deep course about Redis. So I just wanted to give a quick overview of the vector database and how you can query data with the vector information rather than simple text as we usually do on a relational database on any other type of queries or database, right? So I hope it's clear. That's gonna get even clear when you use the real data and when you are doing the performing those query with data for AI agent. Okay, thank you very much. See you in the next lecture.